Hello everyone. First of all, let me thank you to the organizer of 6th International Conference on Inventive Systems and Control. Let me start by saying a few words about my own background. I'm Ilyas Hussain. I'm currently working as a researcher at Time Research and Innovation in Bangladesh. I'm introducing to other authors Mr. Shah Siddiqui, who is a PhD candidate at the University of Portsmouth, United Kingdom. SM Asaduzzaman, Sabila Al Jannah, Tasin Niloy, Wahidur Rahman are the researcher at Time Research and Innovation. Shamsul Masoom, Adrian Hopgood, Alice Good, and Alexander Geoff are the prestigious faculty member at the University of Portsmouth, United Kingdom. And I am to say that this research has been carried out under the supervision of the prestigious faculty member at the University of Portsmouth. Now I am presenting this research paper on behalf of the authors. So let's get started. So this research presentation is structured as the following content, and I will be focusing the key points during the presentation. Having the global pandemic situation, our life has become very difficult, and this is very significant to ensure every individual's life safety during this difficult time. The COVID-19 is a very vital disease, and this is the responsible for every inconvenience that we are facing now. The country began lockdown, economy goes down, and many people are died by developing this disease. According to the World Health Organization, approximately 3.4% COVID-19 mortality rate was recorded in 2021, and this mortality rate is enhanced day by day. And as a result, a vast amount of data are being recorded to the healthcare sector. So this in turn bring us to a big question. Can we handle all the big data by using modern computational approach and figure out the meaningful insight? However, this research has concentrated on those issues and come up with an effective solution. We have proposed a mobile application that can calculate the COVID-19 risk variables effectively. The following contributions are addressed in this research paper. Firstly, we have developed a machine learning technique in order to identify the COVID-19 risk factor. Secondly, our machine learning model will be deployed in the software system to make a robust system in terms of a clinical application. And thirdly, we will make an awareness that will significantly contribute to the society and around the globe. Now, turning into the proposed system methodology. This research methodology is divided into two parts. So to begin with, figure 1 shows the overall research methodology. So by looking at the figure 1, it can be observed that this research is being conducted through the 5 stages. So in the first stage, we have collected the data. In the second phase, the data was pre-processed. In the third phase, we have trained our machine learning model, and in the fourth phase, the predictive outcome was recorded. And in the last phase, the machine learning model was deployed to the web server and accessed through the software system. Now, talking about the proposed software model, the figure 2 illustrates the block diagram of the proposed system. So this block diagram contains the feature module and machine learning pipeline. Taking a close look at the figure 2, it can be observed that the features modules contains the important parameters, and users will have to feed some features like blood pressure, oxygen, lung disease, CRP, and after having those input, the system will forward those input to the machine learning model, and the machine learning model will automatically calculate the risk variable by analyzing effectively. Now talking about the user interface, so this is the interface of our proposed mobile application, and each interface contains an important information starting from feature feeding to the model and displaying to the user. Let me talk about the system usability scale that we have considered in this proposed research. So system usability scale has been considered to measure the usability because whenever we will deploy the beta version and make it publicly accessible, we will constantly collect some data from the users, whether they are using this system is very effectively. So after collecting those data, we will calculate the SAS score, and according to the SAS score, if any system does not achieve the 68% SAS scale, so which indicate that this system is not applicable to the real life. So we will work on those issues, and we will try to increase the usability. So talking about the feature importance, which is very significant while working with machine learning, because uh, unnecessary parameters sometimes slow down the model performance. Rather, we need to find out an effective solution to make an effective features, so that will increase the machine learning model's performance. So whenever all the steps are done, we will assess our model by using the model evaluation indicators. For example, confusion matrix, receiver operating characteristics curve, and k-fold cross validation, because these are widely using model evaluation indicators, and we will use it in order to specify the sensitivity and specificity, and after that we will work on the mistakes. So the resultant discussion and the comparative analysis section. So now talking about the comparative analysis section, our proposed model, which is considered as light gradient boosting machine, that we have considered in this study, and this algorithm has been compared with the state of the art technique. And looking at the table 1, it can be observed that the authors of the previous studies have not yet considered the light gradient boosting machine for their research work, and they did not consider the software system integration to their model. So we have worked on those drawback, and we have integrated the light gradient boosting machines to our research work. And apart from this, we have deployed our machine learning model to the web server. So in that way, we will be able to make a robust system. So to conclude, our proposed system will help both doctors and patients be aware of risk factors of COVID-19 and takes the necessary steps to mitigate the factors and help the COVID-19 patient recover quickly. And our system will be applicable to the real life, because we will work on the system usability scale, and we will assess our model properly, so that this will be achieve the system usability. So in future, this research will be extensive. For example, we will make our own algorithm to take this research into the satisfactory level. Then we will improve the suggested model by training an extensive dataset and figure out the overfitting and other issues in terms of making a robust system. So it was all about our presentation. So if you have any questions, then feel free to ask, or you can email us. Thank you.